And we're moving to our next speaker. Our next speaker will be, as I already announced, Oleg Klimenko. Oleg, welcome to our virtual studio.
Thank you. Thank you, Roman. Thank you.
Yeah.
Hello,
And also,
everybody.
yeah, and also let me invite here the moderator of this stream, Tatiana. Tanya, hello again.
Hi, guys.
Okay, so first question will be to Tanya. Tanya, how do you like our conference? I saw you were on different streams today, so what do you think?
Actually, trying to be everywhere at the same time, I possibly lost some interesting points. Still, I tried to do my best to visit the most beloved topics for me. It was about clouds, definitely, and about some interesting features related to documentation as code, and a bit visited a functional programming talk from Karin. So there was absolutely amazing conference, at least till that point, and I hope and I know that it will be the same way as well during the final talks. So what I'd like to say in general is that I am very happy that I see some people who stay with us during the whole conference. I hope that they had a lot of interesting thoughts taken from this conference, and definitely have had a lot of fun. Yep.
Great, great. Thanks for the comment. So, Oleg, I know it's quite early in your location right now. Am I right?
Yeah, that's right. It's early morning, but I'm ready, well prepared, and excited.
That's super cool. So I ask all the speakers, maybe you can give us some spoilers. Maybe what would be your talk about? How could it be useful for our audience?
Yeah, this is usage of Scala for big data, and this is usage in interactive mode. So this is not our regular use when we prepare everything, get our program ready, compile, embed unit test, and then deploy. This is interactive mode, and this is interactive mode our big data using Apache Spark. That's the difference. And still, this is Java ecosystem.
Okay, that's really nice to hear. So I've heard that Apache Spark supports not only Scala but also other languages from Java ecosystem. So why Scala still?
Well, Scala is just because it's more concise, especially for big data. Less symbols, more powerful tool. Not as fast as Java, but for our purposes, which I will describe, it fit just well.
Oh, I know people who would argue with you about speed of these different two languages, but okay, let's leave it out of the bounds of this talk. So I think we may start the talk itself. So guys, just a reminder, we have 3 chats where you may send your questions. First one is here on YouTube, so just post a question in the chat, we will see it. Second one is on our Discord server, link to Discord server here in the description. You may find it there and join Discord server if you haven't yet. And third chat is on We Are community platform. We monitor all of them and we'll collect questions from all these 3 chats. Also, I want to tell you that this is your last chance to participate in our competition on photo challenge, how you watch Java on. So make a photo, post it to Instagram or Twitter and tag us. And also we have some challenges in our Discord server. So basically this is your very last chance to participate in it. So don't miss it. Okay, saying that, Oleg, Tanya, good luck to you with this talk, and floor is yours. Java is on.
Okay. Thank you, Roman. Thank you, Tatiana, and hi, everybody again. So I will be talking about my latest experience using big data tool Apache Spark and under Scala language. Apache Spark could be used using Python language, but we used it exactly using Scala because for our needs, it fit well, just much more better than using of Python. I will describe it during the course of the presentation. So what we will talking about big data in general, because our projects, recent years projects, they're in this area. I'll describe Apache Spark, a high-level architecture. What's more important than even architecture itself, this is data structures, because for big data, they are special. They should be distributed and reliable and fast enough. These data structures should be stored in proper file formats. And at the end, I will demonstrate live coding. My opinion, using this overview of live coding features, it's enough to start working as junior data scientists using Apache Spark. Okay, so what is big data? Back in the days, in earlier, 15 years ago, it was said that we have free V features to describe the data and to decide if it's big data or a regular kind of data. First of all, volume. If we can't process data using classical relational databases, we should engage big data. Velocity, second feature. So that means we have so great data pumping velocity that we should engage something different from our classical tools. And variety. We have so many different formats that we cannot process it using different classical tools. Nowadays we have added more characteristics to that. By the way, guys, I have a question to you. It would be nice if you send your answers. This is like my opinion, and it's still not settled set of characteristics what we should, according to criteria. But what is big data? Could you please put your opinion in chat? What criteria should be applied for big data besides these criteria I'm talking about? So volume and velocity actually, this is a kind of current hardware limitations. So if we are not able to fit our volume or velocity of data inside disk or inside the broker, that means we need something different. So it doesn't fit within one computer. Variety of data means form of data, like structured, unstructured, and semi-structured. Veracity, this means data accuracy and quality, especially from during integration from different systems. We should check data quality and should not reject improper data. Variability, this is more for Internet of Things when we have a lot of data and some sensors send us incorrect data. We should also filter on inconsistencies. Viscosity means data complexity, and volatility means data durability. And these characteristics, it depends on algorithms. Volume and velocity depends on hardware, and these logical things depend on algorithms. And nowadays, we more dependent on value, business value. What could I extract from my data? Because when big enterprises started to organize data lakes and to put all their data in a single really huge storage, they got lost. They got lost which value they could extract because they missed metadata. And metadata is also really important in big data world, because you can't extract proper data if you do not know the nature of your underlying data. Okay, so types of data. I have these categories: structured, semi-structured, unstructured, and graph. Again, guys, if you have another well, categories, please type it into the chat. It would be nice to see your opinion. Structured data. This is classical data like relational database, supported transactions, and this structured data type, it has quite strict schema validation. Unstructured is another. On the another hand, it's binary data. It's impossible usually to change part of the data. If you change in something, you have a completely new version of this binary object, and schema usually could not be applied automatically to this kind of this type of data, unstructured one. Example is AWS S3 storage. Semi-structured, quite an interesting format. I had several projects engage in XML and JSON storage in database, in MongoDB, in relational databases, because currently relational databases support JSON really well. Why so? Well, one of the project, it was questionnaire survey-based project, and we were able to add additional questions and send out new versions and store answers exactly in the same format, because JSON is extendable. It's quite flexible validation, really interesting format. And graph format, the fourth one, really, well, attractive one, because Gartner predicted at the beginning of this year that this segment of tools, graph-oriented storages, will grow by 100% during this year. This year is not so successful in IT, as you probably know, but still it is growing. It's quite promising, because it is a mixture of data and metadata. And as I said, metadata is really important in big data world. Okay, let's move to the next one. Let's move to the Apache Spark itself. It is a tool, Apache Spark, written, by the way, in Java. That's why one of the reasons we switched to Java ecosystem and then to Scala, because API is more advanced using Java and Scala here. They provide recent features in Scala. So, well, what is it about? This is client-server architecture. One of interview questions for data scientists working in Java would be, what kind of architecture is it? It's master-slave architecture, and this is, and we have two types of nodes here, two types of servers, workers, which perform actually calculations and data storage, and driver. We from our application, we send tasks to driver, and driver, using cluster manager, sends these tasks to workers, which are powerful machines usually. Spark context is a logical thing, or well, I will explain about it a little bit later. It's a main entry point of all their operations. Frequently, Spark is compared with Hadoop because, well, those two tools, they are big data tools, and they have quite a similar approach in processing. They split tasks into stages, and intermediate calculations stored in memory when we work with Spark, and these intermediate operations stored on well, hard drive or storage, permanent storage in Hadoop. This makes Spark much more faster than Hadoop, and I don't really remember new projects recent years starting using Hadoop. Only maintenance, yes, a lot of maintenance for big companies projects, but no new projects using Hadoop. And a lot of new projects using Spark because of its advantages, because here I'm comparing Hadoop and Spark. Spark has lower complexity because it operates high-level API comparing to Spark. And in Hadoop, you should compile, deploy, and then after that you could see your results and if they correct or not. But using Spark, you do not need cluster. You could use interactive mode, and I will show you shortly how it could be used. And the performance of Spark is exceeds performance of Hadoop. Okay, that's the feature. This is their architecture. Spark is quite a mature tool, like more than 10 years on the market. It has a core API available for all major big data languages. It could be run locally, or it could be run using different scheduler and task management tools like Kubernetes, Mesos, Yarn, and different kind of schedules. Spark works with almost all kind of storages: cloud, big data, relational storages, local file system. All these storages are available through libraries embedded in Spark. Spark has frameworks on top of all this. So it's possible to process data using language or SQL. Spark has a streaming framework, a machine learning framework, Graph, which I mentioned, quite interesting one, quite new for Spark, and also new framework, Spark R for R mathematical language. Let's starting to move to programming thing and to practical thing from theory. Main entity in Spark, this is Spark session. It could store different Spark types of Spark contexts: regular Spark context, SQL context, streaming, and Hive for integration with Hadoop. On the left, this is a code snippet from Scala language. I'm creating a master locally, enabling Hive support and making ignition of this session. On the right, I'm creating a streaming context with a window length of 1 second. And this brackets means I'm dedicating only 2 cores of my CPU to these calculations. Spark has this tool, Spark Submit, to send comments to server. It's not so complex, but quite wordy. So we are using address to send task. We are using different deploy modes. I will expand on this shortly. And we are specify resource limits, and we are sending jar file to the cluster. Good thing is modern IDEs like IntelliJ IDEA. It supports all this command in our run tool, run dialog. Let me expand on deploy mode because it's important. Important at least to know. One could not and should not remember all the switches, but theory, how it works and why it's important, and it could be again, a question on an interview for data scientists. So there are three modes: client mode, then we have client, driver, and executor working on local node. This is, of course, a mode for local development. Next one is a kind of also local development and testing, but it engages powerful cluster. So deploy mode in that case is a client. And the drawback is if driver fails, driver running locally, we are in Spark, we are losing all the calculations performing on cluster. So for production, of course, it's recommended to use driver and executor with deployment mode cluster running exactly on cluster. So nothing complex, just important to know. So local or semi-local or cluster mode. Data structures. Data structures are the key of Spark, and actually all the competitors, competing tools, they are started to steal this idea, and you can see like in pandas, in the Python pandas, we have DataSet word, DataFrame word, and similar data structure used. Well, there are three main data structures: RDD, DataFrame, and DataSet in Spark. And one, I'll just right now explain about distributed variables. This is like a short dictionary or Scala variable available on all nodes just for convenience or for counting something. This is distributed variable. Well, quite a simple data structure. But those three are quite important and quite well, complex one because they are distributed. RDD is unstructured data, well, quite first data structure in Spark. It shouldn't be used as it is because it's quite low level. It should be used only if you are going to manage partitions by yourselves, RDD. DataFrame, this data structure is available in all languages, in Java and in Python, in Scala, because it's not typed. It contains a collection of raw objects. And DataSet is a collection of serialized Java objects. So they are Spark serializes object for each row, and it stores remotely, and we are able to perform calculations on the nodes, sending logic to that data. That's the main feature actually. That's Spark is fast. We are not pumping data. We are not transferring data. We are transferring logic to the nodes where data are stored. And we are performing calculations without deserialization of these objects. So this is advantage of data structure. And only this data structure is available in Scala and Java when you're working with Spark Scala or with Apache Spark. Because it's typed, it's not available in Python. So that's the advantage of Java and Scala for Spark. RDD, I'll expand, I'll give more details on each of the data structures, on all of these three. RDD, resilient distributed data set, resilient because it's copied in different nodes. Each portion of data are stored on different nodes. Main feature is immutable. Well, comparing for pandas, Python pandas, it's immutable. In Python, really similar data structure, it's mutable. And when we are working with data structure, we have lazy evaluation, like in our old good Stream API from Java. Only terminal operation invokes all the calculation. This data structure doesn't support any schema, and no optimization is possible for calculations. Starting from DataFrame, well, data looked like these in stored column by column in these data structures, and Spark stores also data type. So optimization is possible here for DataFrame. So we have named columns with data type for each column. DataSet, as I said, is a storage of objects, serialized objects, not available in Python, because well, Python couldn't work with typed such a type of objects. We do need encoders, but Spark provides all kind of encoders to serialize this object for this data structure. Well, that was data, and now we have operations or functions over this data, really similar to, again, Stream API. So this idea of why we are using Scala again, additional argument, because our developers were familiar with Stream API. Like, it's possible to filter, collect, map, count, take first and maximum, minimum, and sorting and reducing. All these functions available from the simplest data structure RDD, and they're available in DataSet and DataFrame too. We have approximate function, which is quite interesting function, especially for click streams or data streams when we are still receiving data, and we are able to calculate some mathematical functions or aggregation functions on our live stream approximately. And of course, RDD could save itself into the file. DataFrame functions, we have for this data structure, for DataFrame, some additional functions. We could show it. By default, it shows first 20 rows. We could select name, and we could perform basic mathematical and string-based conversions. Our values in column, for example, age. We could filter using expression inside string. We could group our data frame by a column and find minimum, maximum, and some other aggregate values. We have even window functions for columns in data frames. So it's really powerful. By the way, I have a question. If you can do a screenshot and type into the chat what this expression actually do. Could you guess? Not knowing Spark, but having just general SQL knowledge. What is it about? Exactly this window expression. Below, I have an example of classical solution of classical task, which is given for SQL developers during technical interviews. Find average salary for split by gender for people over 30 through different departments. So I'm filtering by age. I'm joining people and departments by department ID. I'm grouping by gender, and I'm calculating average for salary and age. So this is close to SQL, but even more advanced. It has more advanced features like calculating different aggregate functions. This expression could be fully convertible to SQL. So actually, the engine is the same, but we could write it in a select columns from a department and people where age is greater than 30 and so on. I will show you example later on how SQL looks like for this kind of. Well, let's make a review of functions or transformations. There are three types of transformations. Narrow means we are able to process data without transferring between nodes. And of course, if we are sending lambda expression in map function, we are able to send this lambda expression to each node, and it will calculate it internally on each node. So like filtering, mapping, those kind of functions are narrow functions working on a single node. Wide transformations, like for grouping, for reducing, sorting, they are, of course, need data from many partitions. But it's potentially dangerous because it could lead to cluster failure if we have a lot of data or perform different unwise joining. Actions, previous functions, they are working our data on nodes, and these actions, they are extracting data to client. So we are able to see count, we are able to extract or take some rows, we are able to aggregate, iterate using for each and so on. So this is actions. I've already told about comparison of pandas. Pandas is a framework in Python. It's really powerful, but it has similar functions I've just explained to you about this count, join, take, and so on. They do have it, but it's more powerful actually. Pandas, I mean, more powerful than Scala. Yeah, that's it. Data are mutable. Pandas exercise eager execution, and it's good. And data scientists love it for ad hoc analysis. But Spark Scala has advantage because it could be still compiled, and it's more production ready because we have our old good CI/CD pipelines here for Java, and we could deploy it on server on cluster. Yeah, and Pandas is single-threaded. So it's like for playing around for single data scientists, Pandas. And Spark is more like enterprise-oriented thing. That's the difference. File format, let's explain about this. Of course, Spark could work with text files, but only if the file contains quite a few number of rows. For files even starting with million records, we should use Parquet, Avro, or ORC data format, which are binary data format. And of course, we have integration with storages. What is the difference? Well, we have two types of file formats: row-oriented and data-oriented. Again, question to you guys. I'll try to explain, but what's your opinion? What is your use cases? When do we need a row-oriented format, and when we should prefer a column-oriented format? Well, I'll explain technical things, and you could please explain business case when we should stick to this or that data format. Row-oriented format stores data row by row, and column-oriented stores data in a separate columns are stored in separate sections or even files, and we are able to fetch rows using the same offset. Say offset number 2, I could find data inside transaction ID by using this offset using account. The advantage is I shouldn't scan all the raw data, and for some types of business operations, for example, for creating ad hoc reports, we have, for example, in Clickhouse tool. I'm not describing this tool right now, but it engages exactly column-oriented format for to be able to fast fetch data for ad hoc reports. But this is only for ad hoc reports, so this is different niche. Why I'm explaining these two types? Because we have exactly two types of binary format, row-oriented and column-oriented. So Avro, it's a row-oriented format. It's usually used in Kafka. It's row-oriented because we are processing row by row, actually, and it's really hard to calculate average age from Kafka topic. We should read all the blocks or all the records. Avro supports schema evaluation, and it has a tool, for example, tool from Confluent named Confluent Schema Registry UI, where we could upload different metadata for using this tool. And metadata is in text format here. That's important, and we could check it well. It's human readable, but data itself is binary, and the Spark could quite well work with this data format, Avro. Parquet is a native for Spark data format. It's space friendly because these files are compressed really well. It's oriented for reading and for querying. So it's like a database stored inside files. It supports a schema for different columns. It could be saved as a file. It could be saved as distributed files, and it could be saved as a local file. So it's good for backup and restore. Okay. Let's compare it to RC file. Again, it's different binary files. It's column-oriented file too. The difference from Parquet, it supports transactions, AC transactions. So again, this is a recap on comparison of row-oriented format like Avro and Parquet-oriented. So in Avro, we are storing row by row. In column, we are storing data in column by column. That's the difference. This is an overview when we should use each format. Avro supports great schema evaluation, schema versioning. Compression is best in ORC. Splittability is good for Parquet, and it's also good on RC. And Avro is row-oriented, Parquet and Parquet and RC column-oriented. JSON, as I said, we shouldn't use it much. It's convenient for start of the projects to exchange understandable data, but it's not for actually big data. Okay, let's do some coding, let's take a look what's actually a Spark using Scala. We have, I will be demonstrating using Jupyter Notebook, old good Jupyter Notebook, just I have changed kernel. We have two projects. One is outdated Spylan, and Almond is a quite good maintained project. It produces Scala kernel for Jupyter. So let me do the demonstration. So I've installed, it's enough to know, just enough to know that and it could be searched inside internet that we could well, use Scala language inside Jupyter, and you will find this Almond and the name Almond, and instructions how to install. I'm not going to install. I'm going just to show how it works. First of all, this coding will consist of two parts. So firstly, I will explain you some technical features, how to work with Scala, which entities do we have, which functions do we have. And second, we will solve real practical tasks for data science. Okay, so first of all, I need to import my libraries. It's imported. Now I'm changing login level. It's quite nosy by default. So actually, this is Maven dependencies. So we are able to import Maven dependencies here, and I'm importing Spark and Almond libraries. Then I'm creating Spark context. I'm assigning all the my CPU cores to this Spark context, and let's create this Spark context, and then let's create RDD. How can I create RDD? For example, I can use a range, Scala range, from 1 to something like million, and split it to 100 partitions. So this is my first RDD containing of which contains int values. Okay, so far so good. What could I do using RDD? I could map. By the way, if I press Tab key on my keyboard, I have some hint. Not IntelliJ idea, but still something. Okay, so using Scala language, I could apply, for example, multiplication by 2 of each item of this RDD, and I could add 1 to and perform some over this function. Okay, this is the result. So what else could I do with RDD? I could convert it to DataFrame. And what if, let's perform some basic operation over RDD. If I'm trying to apply sum, it won't work because this is low level data structure. So you probably remember RDD. So I should tell it, I should convert its internal values to something meaningful. So I'm using lambda function, converting my raw object to some integer data type. And using this conversion, it's possible to perform. So again, this is demonstrations that RDD is quite low level data structure, and we should convert its internal things into something meaningful. Okay, let's play more with this data structure. For example, I have tuples of pairs of string and integer, and using this RDD of these pairs, I could solve quite an interesting technical task. I could find the biggest number of these pairs using this expression. I'll use reduce lambda function of two variables, and I will compare a second variable and return proper variable which is higher. So, and the solution is this tuple containing second parameter number, which is largest for all the tuples. Let's play with saving to data structure, because this is quite an interesting thing to save this file. Let me try to which I use data 5. We may. Okay. Okay, just it's possible to save into data files, but it will be saved in different partitions. If we do want to save it into a single file, into a single partition, we should use calls function. That's again a trick we should not forget when we are saving with distributed data structures. We should first collapse it using calls function. Again, this is an expression. If you can do the screenshot here and type into the chat, we have like 7 or 10 minutes left, and guess what's going on here. What this code using this knowledge we have just I've just explained. We have parallel function, we have mapping function, and actually joining. That's it. What this code actually does? Can you guess? What does this code perform? It's quite advanced, but who knows? Probably. I'm not expecting a lot of answers. Probably no correct answers, but who knows? Guys, just do your guess. What's going on here? Dataset and DataFrame. Let's work with dataset and DataFrame. Import variable and create a context. Here I use zip function. It actually kind of glue of two sequences, left and right, and it creates a tuple. Well, it's actually Scala. It's not a Spark specific, but we could create a data set using this list, and it contains unnamed column. Just Spark automatically numbered it, like column number 1, number 2, and it has this data set has types. But I could map it to class if I declare a Scala class containing name and value. I could easily map it to already serialized functions. And here is the difference. First dataset which I created from a list, it contains unnamed columns, and this second dataset which I created using data row class contains data row serialized objects, and we could have this advantage working with typed object from dataset. What else could we do? What else we could apply from Spark to our dataset? We could extract column, actually add the column. We have just 2 columns, and we could add column name merged, and I will apply concatenation to name and value column and add underscore here. So I added one field, and I can see that I have added some derived data to the data set. Okay, that was just the technical details, playing with simple functions. Let's take a look into a real-life example working with big data. Data for this example was downloaded from Kaggle, quite a known site. We have airplanes through United States for 2018 years, all for all the year, pumped inside a single file. So I could use only binary data here, data file. I'm using Parquet here because I tried to use text file like CSV, but upload speed, it's like ages. So what do we have here? Let's review. We will solve different big data scientific tasks using this data. So we have destination and origin. This is names of airports inside the United States. We have miles per trip, per flight. We have name of company, and we have price of ticket. This is the main valuable. Well, this is the work of data scientists started. In first example, I just played with technical things, with technical features, classes, but here data scientists should understand the data. And he or she should be really expert in the area, should understand and pump this metadata inside his or her mind. So I have this data. It's data frame, but I want to set data set, which is more advanced data structure. For that, I create class, Scala class, flight with all the fields corresponding to the columns from the data file. And I can convert data frame to data set. And now I have typed storage on my cluster. I'm checking. Well, visually, this is the same, but this is not just separated column. It's serialized object, flight stored inside. Okay, so I'm just preparing my Spark context for practical tasks, doing some imports. Okay. Let me correct my path. Okay. So I'm reading my data frame again, checking 1 million rows, showing data. So again, we will be working with airport of origin, airport of destination. We will use airline company and price per ticket. Okay. So first of task, let's calculate correlation and covariation between miles and price. Why this is important? We are going to determine if this is a honest pricing. If correlation between miles and price is the same, then price depends only on miles, and this is honest than pricing. Correlation is like 33%. Persons means price actually doesn't depend on miles, so it's more tricky pricing which company uses. This is one practical thing we could extract this data. And data scientists were quite frequently searching correlation between different fields, different columns, trying to understand, are they related really? And should they be related, or are they actually related? Okay, we could easily define our quite a large data set. Just I'm reminded this is quite a large data set, and we could define different statistical features, like count as simple statistical feature, like mean, statistical mean, minimum, maximum, standard deviation of all this data, which could be used for our scientific models. Let's answer this question. Which company made the most of flights in this year? So for this, I need to group by field named airline company, and I'm going to count it, and I'm going to order by. In Scala, we could overload any symbol, including $sign. It's overloaded here, and I'm using descended sorting, and it should work. It should give me the airline company with the most sorted number of flights. Delta Airlines did the most flights in this year. Okay, we used overloaded symbols, but if we would be in Python, we should use this syntax, like colon, not this syntax using $sign. Actually, result is should be the same. Okay, okay, and I could create a view. Why? Because I need something is happening with my. Okay, I could calculate the same amount of data. The same I could calculate the same result using SQL. So here I have count from flight, group by airline company, order by count descendant. So this is the same syntaxes I'm using for SQL. Okay, let's find average price of all flights performed by the companies. Okay. Let me. How will it look like this average price? Again, I'm calculating data frame. I'm adding where clause. I already know that this company, Data Airlines, did the most flights. So I'm aggregating it, calculating average price, and demonstrating it. Well, time is over. I just will be real quick here. How many companies flew more than 50 million miles for 2018? Again, I'm grouping by company. I'm performing some other miles. I'm just applying where clause to the aggregate function. And the last one function, find average earning for all companies for this year. again, I'm grouping by company. I'm summing price. I'm calculating average for company, and I'm performing casting here. Colleagues, that's basically it. If we have questions, I'm open for it.
Thank you for the great presentation, and especially for the practical part, which was rather interesting and visually demonstrated us great abilities of usage Spark. So as for the questions, firstly, I see some replies to your questions, to the points which you would like guys to check. So the most of answers were about the part with the max in the function, so with the with column, etc., etc. So in the first part, and the most so I see the responses that this is a removal column with max value or a row with max value. Or something like select max p over something as max p where. So what was it in fact, this row?
Well, first one is correct actually. So yeah, thank you guys. Yeah. What about the next one, the next task?
Actually looks like the next tasks were a bit more difficult because they don't see any actual replies. So after that, yep.
Sorry, guys.
Just mainly comments. Hopefully, guys, possibly the so guys who will look at this as watch this as a recording, you also have a great chance to post your questions in the WeAre community platform in the comments section below this speech, and we will also check how attentive you are and whether you guess what actually this part of code was about. So, as
well, actually, this is word counting logic. Word counting in this string.
Yep, that's actually it was my guess, basically.
Yeah, it could be guessed without any understanding of what is going on here. Yeah, word counting.
Oh, okay. So I see Roma is with us. Roma, do we have some time to answer questions from the audience?
Yeah, we have. I just wanted to say that you may leave your comments not only in WeAre community platform, but also on YouTube, where you're probably watching this stream or this video. You may just leave comments below this video, and we, of course, will receive all the information about that, and we'll share it with you.
Yep, cool. Thank you. So we're waiting for your replies, your comments while you're watching this as a recording. And for the ones who are watching us as a stream, continuing the Q&A session. So when using DataSet is preferable to using DataFrame, and are there any trade-offs?
Yeah, this is a good question actually. DataSet is a type safe. So if we want, as I just demonstrated, work with a class, for example, and this class, we know which columns do we have, and we want to work with class as a data object, data transfer object. We should use DataSet. DataFrame, if we just do not care about how internally stored it is, but still we could work with names of columns, with types in DataFrame. And of course, again, most important distinguish here, DataFrame available in Python and DataSet available only in Scala because of this work with typed object. So that's the difference. Python guys, they use data frames in Spark.
Yep, and actually, one more question from my side, since we do not have too much questions from the audience. So you've mentioned several languages with which currently Apache Spark can works, and one of them was R language. So have you had any real examples of usage R in production?
Unfortunately, no. It's well, our language is like a miracle rainbow standing somewhere. Well, this is I've seen this is my like mathematical language. It's really concise, but no, I don't work with. I didn't work with it using Spark.
Actually, fortunately or unfortunately, I did. I saw
Oh,
it in the
really?
project where I'm
What's
working
your
on right
opinion?
now.
What's your
Yep, looks like
it's
so I saw
that's
different experiments with languages across Apache Spark infrastructure in the project. So we have all of the possible options with which basically Spark can work, and R was
wow.
for some kind of rather old scripts, and looks like it was built mainly by also by data scientists who
Yeah,
started to work with some significant kind of bunch of data, and currently for us who need to understand already Java, Scala, and Python scripts in Apache Spark infrastructure, seeing R, it's actually a bit painful. So
painful.
this
Okay.
is something which I wouldn't recommend, because yeah, the syntax quite differs. From both Scala and Python, I think. And yep,
Yeah.
as for me, also it's rather interesting that searching for some. So see, since I'm mainly a Java developer, but still need to work a lot with Apache Spark since last time, I need to search through a lot of ready solutions sometimes, and it's a bit difficult sometimes to find the even proper response in Stack Overflow, because the syntax is so similar in Scala and Python, and sometimes to distinguish which reply is for
Yeah, that's
which
true.
language, it's
That's true.
really
Yeah.
difficult. Yep.
Yeah.
So my question is actually, you already mentioned that there are some specific features which only Scala supports. So, like data sets. Are there any other features which are specific for Scala and can't be reproduced in Python while working with Apache
Well,
Spark?
this is related to release management. So new features are available firstly because Spark ecosystem is being developed and they're releasing new deliverables from time to time. So new features firstly available in Scala, and then they are creating wrappers for Python for these features. So new functions, statistical functions, calculation functions, well, storage functions, they are firstly available in Scala. And you could wait, should wait in Python for these new classes, framework features, and functions if you're working in Python. That's the difference.
Yep, this is kind of, I think, trend in case if something has different languages in implementation, so there is kind of the first and common language which gets all the updates on time, and
Yeah,
after that there are a lot of
right.
wrappers. The same works for clouds or for any other frameworks, I think. Yep.
Yep.
And it's nice to hear that Scala is kind of pioneer for Spark in that area.
It is not so frequent, but for Spark, yeah, it's more native. It's more native
Yep,
Scala for Spark.
exactly. And actually, you've compared Hadoop and Apache Spark, but also sometimes working with kind of in the area near the big data. I heard such framework as Apache Storm, if I remember correctly. So, and heard about some comparison between Storm and Spark as well. So, have you had an experience with that, possibly?
Actually, I don't know. I think no. I probably this is kind of well, it is similar. Yeah, I remember now. It is similar framework Storm. It's for real-time computation, but the difference is Storm is for data streams. That's the main difference. In Spark, we still have like already finalized most cases, finalized data set and data frames, and in Storm we have framework other streams. So that's the difference. There are some intersection because in Spark we have data stream functions, but this is not the strong point of Spark to work with stream. Yeah, there are similarities. They use just parallelization for calculation, but Spark for fixed data sets and Storm for real-time data streams.
Yeah, because I also saw a lot of amazing examples of the real-time processing of huge amount of data using Storm. So I think this might be also the next area which might be kind of interesting to the ones who would like to continue their endeavors in the big data area as well. So, Roma, I think you are waiting for us to wrap up.
Yeah,
finally.
I just could not interrupt such a nice discussion. You know, it's I would be just guilty if I do that. And I understand previous time when I was talking without microphone. So well, anyway, thank you very much, Oleg, for your great talk. Really
Thank you,
great
guys.
talk regarding all this stuff, and thank you very much for being here with us on Java On Conference. Tanya, thank you very much for moderation, for a great discussion after that.